In this video, we're going to do a very classic proof. You can Google this and find hundreds of YouTube videos and thousands of articles and a million different ways that this has been proven. We're going to prove that the square root of 2 is not a rational number. This similar proof works for a bunch of different square roots, so you can adapt this to other things, but this is the classic one that was done. So, let's do our proof. You might suspect, looking at this, that our normal techniques won't work because we don't have an if-then even, right? We don't have if this thing is true, then this other thing is true. We just have a statement. Square root of 2 is rational. Instead of that, let's try and do a contradiction. Let's suppose that it was rational. So, like before, we do it by contradiction. Contradiction. And then we're going to state what that means. Suppose there exists two integers, a and b, in the integers, such that root 2 equals a divided by b, and b is non-zero. A further assumption that I'm not going to write down here, but may be relevant later, is that we can assume that this fraction is in simplified form. It's not going to be written as 4 over 2, it would be written as 2 over 1, as simple as possible. That's a fair assumption to make. There's infinite ways you could write something down as a ratio of two integers, so in general, we're going to assume that it is as simplified as possible. So, now let's try and work with some algebra. I'm going to multiply by b on both sides of that equation. So we get root 2 times b is equal to a. And then we are going to square both sides, and that gives us 2b squared is equal to a squared. And if you look at this, we have a squared is equal to 2 times b squared. That tells us that a squared must be even. So, a squared is even. Therefore, we know that a is even from one of our propositions we proved before. So, there exists a k in the integers such that I can write a as 2 times k. Let's plug that in, and we get 2b squared is equal to 2k quantity squared, which is 2b squared is equal to 4k squared. And now we're going to divide by 2 on both sides of that equation. We're going to do this because then it will hopefully get some more useful information or just a different equation to look at. So we divide by 2 on both sides, and we get b squared is equal to 2k squared. And now we can hopefully look at that and say, we know b must be even. It's the exact same sort of expression we had before. So, b is even. Using the exact same reasoning we used to b squared is even, therefore b must be even. However, we now know that a is even and b is even. That means that a divided by b was not as simple as possible, because if they're both even, they have at least a common divisor of 2 and theoretically more. This means a divided by b is not in simplest form. Which is a contradiction. Therefore, we know that our original assumption that root 2 could be written as a ratio would have to be false, so it cannot be written as a ratio. Therefore, the square root of 2 is not a rational number. And again, if we want to end our proof, you can also write this sort of symbol off to the side. These two diagonal lines is probably the most common one you'll see. But it's something to signify to the reader, yeah, we're done with doing the proof for now. This is the classic proof that the square root of 2 is irrational. You suppose that is true, and then get to this contradiction in that it's not in simplest form. We could have written down that it was in simplest form here. Maybe we would even write that down up here just to be safe. Assume the GCD between a and b is 1. That's another way of saying that, and then we've proven below that the GCD is 2, which is a contradiction because 1 is not equal to 2. So there's our direct, obvious contradiction if we wanted to write it out in a more formal sense.